Hi, my name is Emma Doring, and this is my Physics 2 Lab 1 on charged tapes. The purpose of this lab is to assess the amount of excess charge on a piece of charged tape after doing an experiment where two pieces of tape interact and exchange charge. The models and fundamental principles used were the electric field equation, the Coulomb force equation or Coulomb's law, which states that like charges repel and opposite charges attract, Newton's second law, and the net force in equilibrium. The electric field equation was used to calculate the electric field from tape A, the bottom piece of tape in the experiment. The Coulomb force equation was used to calculate the electric force on tape B from tape A. Newton's second law was used to calculate the force of gravity, and net force in equilibrium, F net equals 0, was used to calculate the electric force from the gravitational force, and also used to calculate the electric charge on tape B. Some general results of the experiment: the electric charge was very similar between the observed model and the computational model. The electrons lost by tape B, 1.18 e to the 11 electrons. The gravitational force on tape B, 1.2753 e to the negative 3 kilograms times meters per second squared. And then the electric force on tape B varies between the models, and we'll talk about that. Some details of the experiment: the system is tape B, the surroundings, tape A, and all other objects. Some initial conditions: D is 0.05 meters, the mass of a piece of tape is 1.3 e to the negative 4 kilograms, the length of a piece of tape is 0.2032 meters, and then the steps of the experiment: I took two pieces of tape, stuck them on top of each other, ripped them apart, and then held them up to different objects to determine their charge. I placed tape B between two cups and held tape A below it as shown, and then I calculated the charge on tape B and used GlowScript to model the pieces of tape as both point charges and line charges. Part 1 of the computational model was modeling the pieces of tape as point charges, so I calculated the force of gravity, the charge of tape B, and the electric force, and the results are shown in the image on the right. You can see that the red arrow gravitational force is opposing the blue arrow electric force, but they're equal in magnitude, so they cause a net force of 0 on tape B, and the charge of tape B is also shown at the bottom. In part 2 of the computational model, the pieces of tape were modeled as line charges, so I used the final charge from part 1 of the computational model as the starting charge, and then each piece of tape is separated into 10-point charges. In the image on the right, you can see the electric field from each of the point charges of tape A, those are the orange arrows, and then the electric force and gravitational force magnitudes are stated at the bottom. When comparing the models, you can see that the electric force is very different between the two computational models, and this is due to the fact that one is modeling the tapes as a point charge and one is modeling them as a line charge or a series of point charges. And in computational model 2, where they're modeled as line charges, the distances between the point charges along tape B and the point charges along tape A that they interact with differ as you move from left to right, and this causes the net electric force to change. The charge of the tape, as we saw earlier, is very similar between the models, and then some assumptions. In the observed model, the pieces of tape have the same net charge, which is evenly distributed, and then the computational models, one is point charges, one is line charges, and then in all the models I neglected all forces that weren't gravity and the electric force. Some possible sources of error: I could have measured the distance between the tapes wrong. I didn't consider all surrounding forces, as I said, and then I could have lost charge on the tape during time in between parts of the experiment where I was touching the tape or it was just sitting there or whatever else. Some discussion questions. So if the electrons were positive and protons were negative, the experiment results would be the same, but the tape would just lose protons instead of electrons, so it would still be losing negative charge. And then the Q values that were calculated by the two computational models were different because, again, the distances between the interacting charges varies in the line charge model. And the line charge model is closer to the real value because the electric charge in a piece of tape in reality is spread evenly across its entire length. That's all. Thank you.